Hi, I'm Klaus from DIAL, and in this video I would like to introduce you to the new feature Obtrusive Light Calculation in DIALux evo 13. When we have a look at DIALux evo 13 and when we go to Calculation Objects, we will find a new icon which is called Obtrusive Light Objects. There you will find special calculation points and calculation surfaces which are needed to do the obtrusive light calculation. There is also a new light scene called Obtrusive Light Scene. This light scene is relevant for the obtrusive light calculation because this light scene sets the maintenance factor to 1. In obtrusive light calculation, we always take the worst case into account, and therefore we need the maintenance factor 1. Everything's new installed, without dirt, without pollution, everything's fresh, and here we are going to calculate the worst case. And that's the reason for the special light scene. But before we dive into the detailed parameters, let's first take a look at the normative standard and guidelines regarding this topic. There are different aspects when we talk about obtrusive light, which is also often called light pollution. Of course, it's a topic about light in outdoor areas, which has a disturbing effect on people and the flora and fauna. Besides the relevant guidelines and normative standards, we will talk about the limitation of illumination on surrounding properties. Next, we will talk about the limitation of glare effects and, at least, about the reduction of sky glow. There are basically two international documents that deal with the topic of obtrusive light. The guideline CIE 150 guide on the limitation of the effects of obtrusive light from outdoor lighting installations, and, among other topics, the European norm EN 12464 Part 2, lighting of workplaces, outdoor work. In addition, there are also many other requirements and recommendations at national level. Please consider which national requirements may apply to your project apart from the CIE 150 and the EN 12464 Part 2. Just one important hint. The tables I'll show in this video are just extracts from the CIE 150 and the EN 12464 Part 2. These illustrations are not always complete and do not contain all the annotations of the original document. Please have a closer look at the original documents when you carry out your light planning. The CIE and the EN categorize the requirements according to so-called environmental zones. First of all, we have the zone E0, which means intrinsically darkness. This is relevant for starlight reserves or dark sky parks, and this is just mentioned in the CIE 150. Then E1, which means dark relatively in uninhabited rural areas, national parks and protected sites. E2, low district brightness, sparsely inhabited rural areas, industrial and residential rural areas. E3, medium district brightness, inhabited rural and urban settlements. And at least high district brightness, which means town and city centers and other commercial areas. Please consider in which of these environmental zones your project is located. If you do not know this, please ask your local authorities. Let's start with the limitation of illumination on surrounding properties, which means that you have to avoid room brightening and the illumination of people's private properties at night. In this picture you see a pole luminaire which causes spill light on the facade and possibly also in the rooms behind it. Just imagine you can't sleep because of so much light in your sleeping room which comes from the outside. When we have a look at the CIE 150 and the EN 12464 part 2, there we will find some values which describe the maximum permitted illuminance in vertical plane in relation to the environmental zones. Also, we will find a hint which says pre-curfew and post-curfew. Curfew regulations mean that's a time or a period of time given by the government or your local authority which is relevant for this setting, for this recommendation. I already mentioned that there are some national requirements apart from the CIE and the EN. Here we see an example from Germany. It's the so-called Hinweise zur Messung und Beurteilung von Lichtemissionen, which means notes on the measurement and assessment of light emission. In this guideline, we don't have environmental zones, but different kinds of so-called construction areas in which the building is located. Here, the curfew regulations are from 6 a.m. to 10 p.m. and from 10 p.m. to 6 a.m. So, let's have a look at DIALux evo 13, where we will find the possibility to check the vertical illuminance. To check the vertical illuminance on a facade or on a window, you can just go to Calculation Objects and take your calculation surface and put it in front of the facade. As you can see, I already did that. Of course, this is nothing new. It could be done before DIALux evo 13. I just would like to show you the ways how to calculate the light emission. So here I just took a standard calculation surface. The calculation parameter I took is a perpendicular illuminance. And before you do the calculation now, it's very, very important to go back to construction and set the maintenance factor manually to 1. This is necessary because, as I already mentioned, we would like to calculate the worst case situation. And in the first step of this obtrusive light calculation, it's not yet possible to put this calculation surface in our obtrusive light scene. So for this purpose, we have to change the maintenance factor manually to 1 if you use a standard calculation surface. But you can be sure in the next versions it will be a possibility there to put this into our obtrusive light scene, that you don't have to change your maintenance factor manually. And here you see the result. We have an average value of 3.73 lux and a maximum of 9.44 lux. You can also take this calculation surface and just put it in front of your window or several calculation surfaces to put them in front of the windows. This could be also done depending on your requirements. Apart from this, there are limit values regarding the maximum permitted average luminance on building facades. These values you will find again in the CIE 150 and the EN 12464 part 2. And on signs also, which means that these are not traffic signs, like advertising signs, for example. The luminance values could also be checked in DIALux evo. Let's just have a look. This check is also very easy. The easiest way would be that you create your buildings as a cube or as an extrusion volume, and then you just may go to Calculation Objects, Results on Surface, then you select the front of a building, for example, and here again you automatically have the values. You have the values for the illuminance and the luminance as well. Of course, it makes sense to change the name. And afterwards, after the calculation, you will have it in the results overview as well. Here you see the illuminance values, 2.43 lux on the average, and here we have the luminance of average 0.39 candela per square meter, and the maximum is 0.9, so absolutely no problem. And before you do this, again, it's very important to set the maintenance factor to 1 manually. Now, let's continue with the limitation of direct glare effects. This also plays a role when we talk about private properties. Nobody wants to be dazzled by a pole luminaire when sitting on the balcony in the evening. The consideration of limit values for glare is also important when you do the light planning for outdoor workplaces. The EN 12464 Part 2 specifies maximum permissible luminous intensity values, as you can see it here on the slide, and these are shown again in relation to the environmental zone and the curfew regulations. The CIE 150 also specifies limit values for light intensity. However, as you can see on that table, it's a little bit more complicated here. The limit values are not fixed. They have to be calculated as a function of the size of the visible light emitting surface and the distance between the observer and the glare source. But don't worry, in one of the next DIALux evo versions, these CIE limit values will be calculated automatically in the software. Now, let's have a look at the implementation in DIALux evo 13, where you will find the possibility to calculate the light intensity values. To calculate the light intensity, first we have to insert a light intensity calculation point. Therefore, we go to Calculation Objects, to our new tool Obtrusive Light Objects, and then to Obtrusive Calculation Points. Here we may activate the last parameter, light intensity. Afterwards, we may place the calculation point. In my example, I have a little building where somebody works, and here we would like to check if the light intensity is according to the norm or if the values would be too high. Maybe somebody is sitting here for lifting up the barrier, and here for that reason I would like to insert a calculation point. So I will just say place calculation object. I will put it here. Here we see the calculation object, and afterwards let's just check some details about the height. If it's a sitting person, the eye height would be in 1.2 meters. If the person is standing, it would be higher, of course, but let's just imagine a person is sitting here. And here you can change the name, of course. What else do we have to do before we start the calculation? At the bottom you will find a little checklist, and we see that we already inserted a calculation object for doing the obtrusive light calculation, but we not yet created an obtrusive light scene. There are two ways to create an obtrusive light scene. One option would be that you press a button Create Now. Another option would be to go to Light, Light Scenes, and create an obtrusive light scene. In that case, it's gray because I already inserted it. It's possible to create one obtrusive light scene in DIALux evo 13. Back to the calculation objects, obtrusive light objects. In the checklist, still there is a little red cross. And here you can define which luminaires should be used for the obtrusive light calculation. we have 22 luminaires in this project, and if you would like to be all luminaires considered for this obtrusive light calculation, I will just press a button Use All. Otherwise, you can select single luminaires and add them to the light scene that only these luminaires are relevant for the obtrusive light calculation. And that's all. The obtrusive light scene allows us to set the maintenance factor to 1. This happens automatically. You just have to do the calculation. And after the calculation, you see in our results overview the value for our light intensity calculation point. It's 2180 candela at this point. If you have already planned outdoor workplaces in accordance with EN 12464 Part 2, then you will certainly know that there are limit values for so-called GR or RG values. Again, this relates to the issue of direct glare. The maximum permissible values can be found in the tables of the EN 12464 Part 2, depending on the type of area, task, or activity. Maybe you know that it has been possible before DIALux evo 13 to calculate the RG values for exterior lighting. When you go to calculation objects, then to our standard calculation objects, down to active calculation objects, here we have a calculation surface, for example, and here we have the possibility in the calculation parameters to select glare rating. Now we have another option, another possibility. When you go to our new obtrusive light calculation objects, calculation point or calculation surface, here again we have the possibility to calculate the glare rating. The difference is that this new feature takes into account our obtrusive light scene. You can automatically use this light scene, and then the maintenance factor will be set to 1. This would not be possible with a regular calculation surface. There you had to set the maintenance factor manually for the global scene to 1. So we now have it in here. And now I would like to place a calculation surface to calculate the RG value. Therefore, I will go into the floor plan view, and for our car park here, I will just draw a polygonal calculation surface. I will just start here, go this way. And now it's very important that you just check this calculation surface, the calculation parameters. It's important that you select this glare rating calculation parameter. The height offset, angle of inclination, step width, that's the same as you already know it from our calculation surface, from our standard calculation surfaces. Here we have something new. You can decide some details about the ambient luminance, how the ambient luminance should be calculated. It's a simplified calculation as per EN 12464, or an exact calculation according to CIE 112. And this is also new. You can define a fixed value for the veil luminance, which means some kind of background luminance. You can select it and enter a value, or this is also new, you can say defined surface. So what does that mean? If we just say simplified calculation as per EN 12464, then when we have a look at the complete scene, the veil luminance will be calculated in the complete scene. And the floor surface, the floor element, the size of the floor element is relevant for the VL luminance. So complete size of the floor element will be taken into account. And for some reasons, you might know that the size of this floor element has an influence or may have an influence on this RG value. Just imagine this situation. We have some luminaires at the back of this building, and of course they have no influence on the glare which might be caused here. But according to this EN 12464 calculation, they will be taken into account, even if an observer does not see these luminaires, because they are part of the scene and they are on the floor element. And if you just would like to take a certain area into account for this RG VL luminance calculation, then you can define a special surface. And therefore, we select this calculation surface I already inserted and select another icon or another calculation parameter which says VL luminance. And this means that the VL luminance for this yellow area will be calculated, and this will be taken into account for this RG calculation when we select it here, define surface, obtrusive light calculation surface number 3. Or, of course, I can also change the name. Then this yellow area will be taken into account for the RG calculation, and the size of the floor element is not relevant. The VL luminance also depends on the reflection factor of the floor elements. And here you can define a reflection factor. You know 15% is just a standard value. And if you do not know any details, you can leave it like it is. Or you can also press this button, determine from scene, which means that DIALux automatically calculates an average value depending on the reflection factor, depending on the colors of the surfaces which are under this yellow area. I will just do it as an example, determine from scene, and here you see in our case we have 24.74%. So this is relevant for the VL luminance, but it's up to you if you would like to do it standard calculation according to EN 12464, CIE 112, if in your project it's clear or it's given that the VL luminance should be 0.1, 0.15 or whatever, or if you would like to have the VL luminance calculated by an individual calculation surface. So I already inserted an obtrusive light scene and I defined the luminaires which should be relevant for this, and so I can do the calculation once again. And after the calculation we see the details. You see here we have the glare rating value, it's 32, and the target value should be less than 50. Where does the target value come from? The target value comes from our user profile. This is here, parking areas, medium traffic. This is a setting out of the EN 12464 part 2. And maybe you remember where you can define this or where you can change it. If you go back to construction, to the spaces, when I select it here, we have this medium traffic. When I go to details and go to the glare limitation, here we have the value of 15, and this DIALux automatically knows, and therefore we have this target value and the check if the target value is fulfilled or not. So in that case everything's okay. And finally, there's a proportionality factor K. While the distance has no influence on the luminous intensity values of a luminaire in a specific direction, the distance between the light source and the observer is taken into account in the formula for calculating the proportionality factor K. Limit values for this factor can also be found in the annex of the CIE 150. And again, in the German guideline, which I already mentioned, Hinweise zur Messung und Beurteilung von Lichtemissionen, or Notes on the Measurement and Assessment of Light Emission, we will also find limit values for the factor K. Again, depending on the type of area and on the curfew regulations. In DIALux evo 13, we've implemented a calculation surface and a calculation point for the factor K. Just let's have a look. I will go to Calculation Objects, then to our new icon, Obtrusive Light Objects, and here we see the obtrusive light calculation surface, and we have a parameter which is called glare index Ks. But before we do the setting, of course, we have to insert this calculation surface, and you have to take into account where this glare might be, in front of a facade or in front of a window. And for that reason, I will just place a rectangular calculation surface again on the top of our facade we have here, and I will place it like this. I will just enlarge it a little bit. So let's go to 8 meters and 30 meters in that case. I will lift it up a little bit that it has no contact with the floor element. Okay, here we are. And then I select the surface and go to the calculation parameters, Ks. Here you can also define a height offset or the value of the ambient luminance, but let's just take the standard values. And in properties, of course, you can change the name. It makes sense because otherwise everything is called obtrusion light calculation surface, and you do not know afterwards in the documentation where you will find your values. So I always recommend people to change the name here. After we did that, we can also start the calculation. When the calculation is done, the results overview will be opened. And here you see our glare index K. And we have a maximum value, as you can see it here, of 1901. On the average, 58. You automatically will see isolines for this value and a value chart on the facade on our calculation surface. Please note that these values are not illuminance values or luminance values. These are values for the factor K, which have been calculated. So we do not have 198 lux or something like that on that facade. It's the value K. It's a factor K. You see here the values we have. In the last part of this tutorial, we will address the topic of sky glow. Sky glow should be avoided as much as possible to protect flora and fauna. Additionally, avoiding sky glow can also reduce the energy consumption. The proportion of the luminous flux that is emitted towards the sky does not contribute to effective illumination. Let's first have a look at the downward light output ratio, RDLO or DLOR. This is a proportion of light that is directed straight downward. Downward refers to the area below an imaginary horizontal line, illustrated here in orange. If the luminaire emits no luminous flux upwards, then the downward light output ratio corresponds to the total light output ratio of the luminaire. When we tilt the luminaire, a portion of the luminous flux is emitted above the orange line. This portion is referred to as upward light output ratio, RULO or ULOR. Both together, downward light output ratio and the upward light output ratio are referred as to total light output ratio, RLO or LOR. Then we may calculate the ratio of the upward light output ratio to the total light output ratio. This is called upward light ratio, RUL or ULR. The CIE 150 and the EN 12464 Part 2 provide guidelines on the permissible limits of this ratio. Here, again, there are values depending on the environmental zone. Finally, we have a look at the reflection. The upward flux ratio, RUF or UFR, takes into account both the directly upward directed luminous flux, the upward light output ratio, and the luminous flux that reaches the sky through reflection from surfaces such as the ground or building facades. And again, in the CIE 150, you will find some limit values regarding the RUF, depending on the environmental zone and the field of application, road, amenity, or sports. So let's just have a look where you will find all these values in DIALux evo 13. Maybe you already recognized that in our results overview, after inserting an obtrusive light scene, the RUL, RDLO and RULO will be calculated automatically for the complete obtrusive light scene. This is what you can see here. But we did not yet calculate the RUL value. And again, when we go to our calculation objects, to obtrusive light objects, here you will also find the calculation parameter RUF, which considers the reflection of the floor and the reflection of the facades. I already inserted a calculation surface here, so I will just take this calculation surface in addition to calculate the RUF value. So I just pressed this button for the calculation parameter RUF, and here you will see some settings which could be defined. First of all, the reflection factor. It's a standard 15%. Again, you can also determine the reflection factor from the scene, which means that DIALux creates an average value depending on the reflection factors, on the colors which are under this yellow calculation area. It's an average which will be taken into account there. You can also type in something manually if you know it exactly. Otherwise, just leave it like it is. And then we have a target illuminance, which means how much lux are necessary on the average to illuminate this calculation surface. And this is very important because the CIE says everything which is not necessary to illuminate this scene according to the normative values is are not really needed. So this RUF calculation considers also this target illuminance. That's the reason. You can type in your target illuminance manually, which is necessary to fulfill the normative standards. Or you can just say adopt from profile, and here we have 10 lux. Again, where does it come from? This comes from our profile. Here our space, parking areas, medium traffic. When we go to the setting, we see visual task 10 lux. DIALux automatically knows this and inserts this value in our RUF setting. So I will just select it again. And yeah, that's all. Again, we can just start the calculation and have a look at the results. After the calculation again, we see the results overview, and here when you have a look at the global obtrusive light results, on the top we see the RUF value, upward flux ratio, and here we calculated a value of 6.38. I hope this video was helpful for you. If you have any questions or comments, please let us know. The easiest way to get in touch with us is through our DIALux community, community.dialux.com. Here you can interact with other users and share your wishes and questions with us. Thank you for watching, and bye-bye.